All right, so today's warm-up problem is just another angular linear velocity question, just to remind you what we did yesterday. Are we seriously going to do this? Oh, wait a minute. It would work way better if I plugged it in. Please work, please work, please work. Oh, thank you. Okay, a Ferris wheel has a diameter of 30 feet, okay? We're actually going to do a lot of Ferris wheel questions eventually. Everybody knows what a Ferris wheel is from the carnival or something. This is a ridiculous picture of one, yes, but I don't know. You walk up some steps and then you get on, right? And it goes around. Okay, what we need to know is this one has a diameter of 30 feet. We are going to need the radius. So what would the radius be, guys? 15 feet. Okay, whoops. Are we seriously going to have trouble with the pen again? If it once every 48 seconds, we're going to say it rotates once every 48 seconds. So right now, it's going 1 revolution every 48 seconds. How do we make that an angular velocity? Do you remember from yesterday? We can't have revolutions. We have to have what? I don't think you have this question. It's just a warm-up. So 1 revolution is how many radians, guys? 2 pi radians. Yep, the pen is gonna not work. Okay. So we end up with 2 pi radians over 48 seconds is our angular speed. And we're supposed to get linear speed in feet per second. The formula we developed yesterday. Boy, that doesn't look like a W. So 2 pi radians per second per 48 seconds. I didn't bother to reduce because I'm just going to type it all in the calculator anyway. Times a radius of 15 feet. This label will go away. So up top, 15 times 2 pi would be 30 pi over 48, and that is feet per second. Can someone type that in and get me a decimal real quick? 30 pi divided by 48, 2.2? Okay, feet per second would be the speed. Did y'all try some of those last night? Anybody have a question on the homework? All right, so today we're going to revisit, is this 8B or something? Can anybody? Yes. Aiden, this is for you to see your counselor, and it looks like it's pretty soon, so. This is 9A? Okay, thank you. So we actually already talked about this, so we don't necessarily need to do all of this. We already took these exact notes at the top of something else, so I just want to revisit. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. We use the phrase, all students take calculus, because all the functions are positive in quadrant 1. Okay, in quadrant 2, if we'd write students, that would mean the sign is positive. The S stands for the sign is positive. And its reciprocal is also positive. Guys, can you tell me what the reciprocal of sign is? Cosecant. Okay. Down in quadrant 3, it would be all students take. That stands for tangent is positive. And its reciprocal, which is, and then in quadrant 4, the phrase was all students take calc. And that C stands for cosine is positive and its reciprocal. Secant. Okay, we already did these 4 questions. I'm not going to go there today. But I wanted to revisit that stuff because now we have to figure out what quadrant to draw this in, starting down here with number 7. It says the sine is a positive 8/17 and the tangent is less than 0, which means it's negative. Okay, all students take calculus. The sine is positive in quadrants 1 and 2. Everybody with me? And which one would have a tangent that's negative? This is all positive, so it would be quadrant 2, right? So that is a question it will ask on the quiz. It will specifically say, what quadrant did you find this to be in? And then what you want to do is draw it in quadrant 2, because if you draw your little bow tie triangle in quadrant 2, it means opposite is 8. Everybody good that sine is opposite over hypotenuse? Okay. So we have 8 and 17, and our angle is in here. When we draw it there, that hopefully reminds us that when we do Pythagorean theorem, what kind of a number are we going to put here if it's going left? Negative. Yeah, we have to remember that this is going to be negative. All right, this one is nice because when we do leg squared plus missing leg there squared equals hypotenuse squared, I believe we get 225. Someone check me. And when we square root that, we get 15. Am I right? All right, but we have to make it negative, and that's the most common mistake, is people forget based on the quadrant that it's going to be negative. So can you tell me these real fast? Cosine is adjacent over hypotenuse, which would be, yep, tangent. Someone else? Maddie, can you tell me tangent? Good job. Cosecant is just the flip of sine. That one was given to us, so it would be 17/8. Secant is the flip of cosine, so it would be negative 17/15. Wherever you want to put the negative is fine. And cotangent would be negative 15/8. All right. I'm thinking we should at least talk about how to draw these. But I don't think we should bother to do all 6 functions for all the rest of these, because it just sounds like a lot of time. Cotangent is negative here, -4. And secant greater than 0 means the secant is positive. I need a few more clues to help my brain, though. If cotangent is negative, what else is negative? Tangent is negative. And if secant is positive, that means the reciprocal cosine is also positive. I just think that would help me think about what quadrants. So all students take calculus. Cosine is positive. These members stand for what's positive. So cosine is positive over here. But if the tangent is negative, we can't be in the all quadrant. So we must be down here, which is quadrant 4. And then when we draw the triangle in quadrant 4, it looks like this. How would we label this? They gave us cotangent is -4. What does that mean? Can you tell me tangent at least? Flip it over and you'd get -1/4. Everybody okay with where I got that number? If cotangent was -4, the reciprocal is tangent is -1/4. So from this angle, opposite over adjacent. Can anybody tell me what the hypotenuse would be? 4 squared, 1 squared. I'm thinking square root of 17. Is anybody agreeing with me? So Let's do one more function and be done. How about we do sine? What would the sine be? 1 over square root of 17, which would become or just negative root 17 even. You can put the negative 1, I don't care. I think that's enough, yes? Okay. Let's just practice drawing at least one more here and figuring out which quadrant it is in. If cosecant is negative, that means what? Sine is also negative. And actually, the sine would be negative 2 over square root of 5. If we wanted to flip it over, we'd have to do more with it, but we'll leave it for now. And it says cosine is what? What is that symbol? That's a less than. Everybody good? Less than 0. So, oh, they're both negative. Where are sine and cosine both negative? All students take calculus. Remember, this is what's positive. So where are... Can't be where sine is positive, can't be where cosine is positive, so it is quadrant 3, because tangent is the only thing positive in this quadrant. Now, if we labeled opposite, it doesn't matter if you label cosecant is a flip of sine, so it's hypotenuse over opposite. So I have a square root of 5. And opposite is a 2. It was negative, though. Do you remember me saying that the radius is always positive or the hypotenuse is always positive? So the 2 is what's negative because it went down. Does that make sense? That one had to be negative. And actually, this one is going to be negative as well. So if we do x squared plus the other leg squared equals the hypotenuse squared, we'd have x squared plus 4 equals, what is the square root of 5 squared? Just 5. So if we subtract, don't we just get 1, guys? But it's going left, so we have to put negative 1. All right. Could you finish that if you had to? All right, let's move on. These are really, 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 really important definitions eventually, okay? Like starting today. When we have a triangle anywhere, when we use those bow tie triangles, opposite of that is really talking about what kind of a value, guys, if it's going up and down. A y value. Everybody see what I'm talking about? This adjacent is really going left and right, which is an x value. And instead of calling this hypotenuse, they will call it the radius because it is as though there was a circle here at the origin. That's the hypotenuse or the radius. What that does is gives this formula, the radius r is just x squared plus y squared, or you can square root it to find r, or it's r squared, whatever. And then the sine is y over r, cosine is x over r, and tangent is y over x. These are super important for the unit circle, okay? So the most important thing you can do right now is just remember that cosine is x and sine is y, okay? Cosine is x and sine is y. And then you also need to know tangent. Tangent, okay, is y over x, not x over y. Do you have some of this? Do you have space for this? You have this in your notes? Okay. Those are really the three you need to know, that cosine, or yes, cosine is x and sine is y. Okay? Because then the rest are just flipping them over, right? I just remember it because cosine and sine alphabetically match up with x and y. Does that help remember it? Okay. And tangent, we're going to talk about this eventually, but tangent is really slope. Do you remember the slope is change in y over change in x? I don't think that's going to help you remember it right now, but tangent is y over x. Okay. So we're going to use these skills. Remember our 45, 45, 90, and 30, 60, 90 from just a couple days ago? We're going to use those to do some questions here. I'm going to actually skip that last slide for a second and see if we really need to do that. All right. Let's do the degrees one first, okay? Number 2. You have this question? Is it number 2 or is it number something else? Oh, you don't have the graph. Okay. I just gave myself a little head start here. So 210 degrees is past 90 and past 180. Does that make sense, guys? 210. Okay. 210 degrees has what reference angle? Can you tell me that? We did reference angles the other day. How far past 180 did it go? So 210 minus 180 is 30 degrees. So now when you draw your little bow tie triangle here, we need to put numbers on it, and you're not given anything. But you do know some numbers for a 30, 60, 90, right? So could we say this short leg over here is 1? But it would be going down, so it'd be negative, right? So if the short leg was 1x, what would the hypotenuse be? 2x. And the long leg would be x square root of 3. I'm getting a lot of blank stares. Yeah, it is going to be negative. Very good. Remember this, across from the short leg is x, long leg is x square root of 3, and the hypotenuse is 2x. So I just don't want to put an x there, so I just put a 1 for 1x, 2x for the hypotenuse, and long leg is square root of 3x. But, was that Jada? Said we went left and down in this quadrant, so we have 2 negatives. So cosecant is the flip of sine. So instead of opposite over hypotenuse, it's hypotenuse over opposite. So I'd have 2 over negative 1. Does that seem right, guys? Okay. I'm not going to have you do them this way. We're going to use the unit circle to do these anyway. I guess let's do number 3 just because it is the other triangle, and then we'll move on. This negative 315 means you're going this way, because you'd go negative 90 and then negative 180 and then negative 270. Or you would just add 360 to it and get a 45 degree. Would that be what most of you would do? So it is a 45 degree reference angle. Now, does anybody remember that pattern? Both of the legs are the same, and the hypotenuse is that number times square root of 2. So if we just put here 1, 1, and square root of 2, so what would the cosine be? Adjacent over hypotenuse would be adjacent over hypotenuse for cosine. So we'd have 1 over square root of 2. We didn't need any negatives because we're in quadrant 1. And that rationalizes to what? Square root of 2 over 2. Okay. before I go too far, we're going to start talking about the unit circle, and we're going to use the unit circle to do these, so I don't want to do any more by hand. It's kind of silly. I want to talk real quick. Do you see these have the same denominator, guys? What happens when I change division to multiplication, I flip the second one over, right? So what happens is that goes away, and I get 3/7. Here, when I have a square root of 3 over 2, and I flip that over, you don't need to write this down. What happens is the radical goes away, right? Or the denominator, sorry, cancels. That always happens. So in just a second, we're going to have to do things like take this ordered pair, and we're going to say the y over the x. So we're going to have to do this divided by this. But what always happens is that the denominator goes away and you just get this over this, okay? It always happens. So as long as they have the common denominator, if I tell you to do y over x, it's just the numerator over the numerator, okay? I'm just trying to save you a whole bunch of time when we get to the unit circle. When you divide, if they have a common denominator, it's just going to cancel. So if I say y over x, you're going to put square root of 3 over 1 and not worry about the denominator. If I said x over y, you'd have 1 over square root of 3. All right. The unit circle. Okay. This says what we do when we take the stuff we were doing over here. Let me back up to this slide. This is where the unit circle comes from, and a whole bunch of you are going to this is going to go right over your head. Don't get all confused. They take these functions that we just drew on here, and they want to make the radius 1. What would I need to divide the radius by to make it a 1? I need to divide by 2. So that's what they do. They divide everything by a 2. To make this have a radius of 1, I would need to divide by square root of 2. So when we get to the unit circle, the radius will always be 1, and then that's where those come from. But all they want us to fill in here is if the radius is 1, okay, then sine is y would be opposite. Everybody agree that? That would be opposite. So sine is y over the radius of 1 is just y. Okay, as long as we're on the unit circle, the sine is y. Cosine is adjacent, or x over 1, because we're talking about the unit circle. What about tangent, though? Opposite over adjacent, look at my picture here, would become y over x. Remember, we just talked about that. Okay, flip this over, and you'd get the reciprocal, and this one would be x over y. Okay, does anybody remember what I wrote a second ago? The x is always the cosine, and the y is always the sine. All right, I will teach you how to remember or work on all these radians to degrees, okay? But what I'm going to have you do, we're going to work on the ordered pairs next, and then we'll do the radians to degrees either at the end of the hour or another day. So this goes like this. It is a 30, 60, 90. So here's my 30. Guys, I want to make this as easy for you to memorize as you can. Which is bigger? It's a 30, 60, 90, so it's got a 1 and a square root of 3 and a 2, right? This little bit is shorter or longer than the x, which is longer? Clearly, the x is bigger than the y, yes? So which is bigger, square root of 3 or 1? Okay, I know I'm confusing you. Okay, if we had to put, this is the 1, this is the square root of 3, and this would be 2. But remember what we just talked about? They made the radius 1, so they divided everything by 2. So they went over square root of 3 over 2 and up 1/2. If you can just remember those two numbers, the trick is students get them in the wrong spot. But clearly when you're going only 30 degrees around, you go over further than you go up. That's what I'm trying to help you remember, okay? What happened when we were at the pi over 4, though? We talked about this one here. Do you remember what this was? The cosine was square root of 2 over 2. So this is square root of 2 over 2 because we're at the 45. And if it's a 45/90, what's happening? The x and the y are the same. So this is also square root of 2 over 2. Now when we get around the circle and we've gone 60 degrees, if I draw that triangle in, what do you notice about the x and the y? The x is shorter, right? So the x is the 1/2, and the up is a lot longer. It's square root of 3 over 2. Now, if this is a unit circle, what is this ordered pair right here? I went over, remember what a unit circle means? The radius is what? 1. So I went over 1 and up 0. And what did I do up here then? Over 0 and up 1. I literally have to say those or I get the ordered pairs backwards. It's how many years I've been doing this? So don't write the ordered pairs backwards. Okay, if you can memorize that right there, you're golden. Okay? Because the symmetry of the unit circle, look back here. Oh, okay, look at your peach sheet. Just kidding. It's not filled out here. Look at your peach sheet. Don't just copy it. But if this was over further, square root of 3 over 2, then 1/2. Remember the bow ties? This is the same triangle, isn't it? But I'm going left. So I'm going left, square root of 3 over 2, which this looked like it was negative. It was my pen. And up 1/2. Okay? And this one we said was square root of 2 over 2, square root of 2 over 2. So this one I'm going left, square root of 2, and up square root of 2 over 2. What page is this on? 10A, thank you. All right, and this one up here, to get up here, remember I wasn't going over very far, but I was going up a lot. So I'm going over 1/2. It's a 30, 60, 90, so I got those numbers, not square root of 2's, right? And up square root of 3 over 2. So if I'm going to the same triangle but left, what do I have? Negative 1/2 and square root of 3 over 2. All right, and this one was over 1 up 0, over 0 up 1. What's this guy right here? Negative 1 and 0. Okay. So what is the reference angle for this guy down here, 7 pi over 6? This is how much turn? It's a 30. So it's the same as these. If I folded my paper in half, this would match up, right? So it's the same as this one, except what happens to the signs? Yep, I went left and down. Where's the other 30? The other one that folds over and matches up is over here at 11 pi over 6. So it is also a square root of 3 over 2 and a 1/2, but I went right and down to get to that spot. Is this helping anybody? Okay, now all those 45s, I'm not going to try to draw all those in, but the 45s are the pi over 4s, right? So it's square root of 2 over 2 and square root of 2 over 2. But this quadrant, they're both what? Oh, that's so messy. Down in quadrant 3, they're both negative. So I get negative square root of 2 over 2 and negative square root of 2 over 2. And in this quadrant, it would be to the right square root of 2 over 2, but down square root of 2 over 2. All right, then I'm back to going over just a little bit and down a lot. So that would be a 1/2 negative square root of 3 over 2. And in this quadrant, they'd both be negative. And what's the one I'm missing in the middle, guys? Across 0, but down 1? So I hope yes.
Did you switch the order in quadrant 3 for the negative 1/2 and then the negative square root of 3 over 2?
Because do you see you're going over a little bit and down a lot? So over a little bit and down a lot. It is the reverse of the 30, 60, 90 because it's the 60, 30, 90.
So that's the only one that switches.
It switched here. I'm not sure what see, all the purple ones have the 1/2 first.
Yeah. Oh. Okay. Never mind.
You're okay?
I just now realized.
Okay.
I was confused for a second.
No, you're fine. I didn't know how to explain it better. Sorry. Okay. Questions? So I guess the big takeaway is that if you can figure out the first quadrant, then everything else just repeats. And watch your signs. We still got to talk about degrees to radians, and I get that. But we're going to talk about how you actually use that unit circle now. Oh, there's a little chart underneath, yes? Okay, positive trig values. All students take, calculus. This would mean also then cosecant, cotangent, and secant. Okay, and this is just to help you, again, sine is what? Y value, cosine is the x, and tangent is y over x. So this is the reciprocal, and x over y. All right, now we're going to talk about why we use that unit circle. Anybody need more time? All right. Do you have this question? Somewhere? What page is this on? 10B? Okay. All this means is you go to 7 pi over 6. Can you find that on the unit circle? 7 pi over 6 is right here. And you write down the cosine. Which one is the cosine? The x. The x value. You're done. Number 2 says go to pi, which is this one, and write down the sine value. What's sine again? The y value. So we write down, you know what? I forgot can you write down the ordered pair? Because this will help me give you partial credit on the quiz. if I know you at least got to the right ordered pair. So I'm going to practice having you write the ordered pair, and then cosine was the x. So this one, the ordered pair was negative 1, 0. Oops, I didn't mean to square that off. And then the sine was just 0. All right. Number 3. Oh, want to change it to degrees right away? This is my hint, guys. If you go regular 3 pi over 4, where is that? It's right here, yes? So it went past one quadrant and halfway through the next. So what is a negative 3 pi over doing? Negative 3 pi over 4, sorry. Instead of going one quadrant and halfway to the next, it's doing it this way. So can you figure out where that is without converting it to degrees? I don't know. I usually don't convert it to degrees. If you convert it to degrees, it's going to be negative 135. If you add 360 to that, you get 225. Somehow we got to figure out where it is. Okay, write the ordered pair down. Okay, what is secant? It's a flip of cosine. So this is the cosine. Doesn't matter, they're the same anyway, but you could write it this way. I don't suggest that. That's just gross, right? Let's just flip it, literally. So it is the reciprocal of cosine. So when we flip that over, we get this. And it's negative. What do we still have to do? Yes. So we get negative 2 square roots of 2 over what? 2. So that simplifies to simply negative square root of 2. If we've done enough of these, you might memorize that flipping over square root of 2 over 2 just becomes square root of 2, but don't worry about it. Take your time, write it out if it makes more sense. All right, we got a quadrantal angle here, 270. 270 is down here, so the ordered pair is just 0, negative 1. Okay, we haven't done a tangent or a cotangent yet. Did you remember? Tangent was y over x, right? So cotangent is x over y. So what is 0 over negative 1? Use your calculator if you're not sure. 0, right? As long as the 0's on top, it's 0. Number 5, pi over 2. Can you find that ordered pair for me? Okay, pi over 2 is right up here. The ordered pair is 0, 1. What is the definition of tangent again? Y over x. So if I put 1 over 0, what happens when I type that in my calculator? 1 divided by 0. So you write undefined. Negative 240. Now you could use, like, here's 240, so it went 3 and all the way around, 2 full quadrants and into the third, and you're going in the negative direction. Or could you just add 360? It's going to be the same place, okay? If you add 360, you get the sine of 120. So what's the ordered pair there? Ordered pair at 120 is negative 1/2, positive square root of 3 over 2. So which of those is the sine? Yep, sine is y. So it's just square root of 3 over 2. Now do you see why knowing that unit circle is handy? Okay. They do get a little tricky and messy. 4 pi over 3, thankfully, is on our unit circle. We don't have to convert anything. Is it this guy? I can't. This one's tiny. So it's negative 1/2, negative square root of 3 over 2. Now, I don't know if you remember that slide where I did all that to flip the fraction over thing? That was to show you that when you put y over x or x over y, the denominators go away. So cotangent is x over y. So the denominators will go away. I only need to worry about the numerators. It is a negative over a negative, so it's going to become positive, right? But we got to do that whole square root of 3 garbage. So we end up with what? Square root of 3 over 3. And the two negatives did make it a positive. Which hopefully makes sense, yes? We're in quadrant 3 where tangent is positive. All students take calculus? Okay. Can you find negative 60? Yeah, it's at 300 down here. So the ordered pair is 1/2 negative square root of 3 over 2. And tangent is y over x. So if I put the y value over the x value, what is that going to become? I don't have to worry about the denominators. I just get negative square root of 3. I think it will really help if you write the ordered pairs down, and it will help me know what it is you understand and where you got lost. Because maybe if you wrote the wrong ordered pair down but did the function right, then I know it's... Okay. Now, here's another one where you could change this to degrees. And actually, it wouldn't be hard to do because you can just look on here. 5 pi over 4 is 225, okay? But it's negative. So, again, normally 5 pi over 4, you'd go around that way into the middle. It's negative, so you're going around halfway this way and ending up here. Does that make sense to anybody? Okay, so the ordered pair is negative square root of 2 over 2 and positive square root of 2 over 2. Which one do we have to do the reciprocal of? Yeah, we need the reciprocal of sine, which is y. So we got to flip the y over. Anybody remember what happened? Yeah, it just becomes 2 square roots of 2 over 2, or just the square root of 2. Like I said, if you've done enough of those, you'll probably remember it's just square root of 2 eventually. All right. Maybe change this to degrees. Look on your unit circle. What's 2 pi over 3? It's 120, right? So this is really the same as a negative 120. If we add 360 to that, we get 240. So this just is another way to think of it. Somehow you got to figure out where you are. So we are at negative 1/2. Oh, that's really messy. Negative square root of 3 over 2. And we need the cosine, which is the x. So it's just the negative 1/2. All right, are you getting a feel for these? Okay. Your homework is some delta math tonight. It's called unit circle trig practice, okay? And you need to work on memorizing the unit circle. I know we don't have time. Yeah, we have no time. All right, have a great weekend, guys. Maybe I'll make a little video during my planning about how to memorize the unit circle, and I'll post it in the classroom, okay? So I hate that I didn't get to showing you how to do radians to degrees quickly.